Example 7 says, a tank is full of water. Find the work required to pump the water out of the spout. What I'm going to do is I'm going to draw my y-axis and my x-axis. And if I'm looking at the front of the tank, I want to draw a two-dimensional cross-section. And what that's going to look like is I'm going to have a triangle. So this is the front of my tank. And based on the dimensions, here we have the origin, so that's 0, 0. This point here is 0, 3, because the height of the tank is 3. And then that ordered pair there, I know that the total width there is 3. So if I were to cut that in half, then this ordered pair would be 1.5, comma 3. Now, what I'm going to do is I'm going to draw a cross-section of water, because we're trying to find the water or the work that it would take to draw or pump the water out of the tank. So here in my three-dimensional picture, what that's going to look like is I have a slice of water and its shape is a rectangular prism. It's going to look something like that. So my goal is to right now find the volume of this slice of water. And because it's a rectangular prism, so volume of cross-section of water, which we just said is a rectangular prism, that is equal to length times width times height. So the length here is constant because we're going from here to here, and that's 8 meters. So that is equal to 8. So that's the length. And the width we're going to figure out based off our two-dimensional picture. So we'll save that for now. Let's talk about the height. The height of our slice of water is delta y. Okay, so that's the height. The way that we're going to figure out the width is we need to figure out what is the distance from here to here. If this point right there is x comma y, and then I need to basically combine it with that there. So what I want to do now is I want to use this ordered pair and this ordered pair to create an equation for my line segment that I'm highlighting here. And the reason that I want to do that is so that I can find the width of my slice of water. So if I'm using my slope formula, I am basically going up 3 units and then right 1.5 units. So if I think about this as rise over run, and that simplifies to 2. So then, because my line segment is going through the origin, if I am setting this up to look like y equals mx plus b, I end up getting y equals, my slope is 2x plus 0. So I'll just leave it as y equals 2x. Now, what I have is that this distance is x, and this distance is also x, and therefore the width of my slice of water in total is x plus x, which is 2x. But because right here we have delta y, that means that we're going to eventually be integrating with respect to y. So instead of writing 2x here, I'm going to write its equivalent in terms of y, which is y. So I have 8 times y times delta y, and that represents the volume of one of my cross-sections. Now, why is it that we're finding volume? It's because we have the relationship that mass is equal to density divided by volume. And so, oh, that's not right. These should be switched. The relationship is that density equals mass divided by volume. And if I solved that equation for mass, then we end up getting that mass is equal to density times volume. Okay, so we found the volume. That was 8 times y times delta y. And if you don't know this, the density of water is 1,000 kilograms per meter cubed. So I'm going to take 1,000 and I'm going to multiply the density times the volume that we just found, which was 8y delta y. So why were we searching for mass? Well, we know that force is equal to mass times acceleration. So I can take the expression that we just found, 8,000 y times delta y, and then I can multiply that by acceleration due to gravity, which is 9.8 meters per second squared. And if I multiply those together, that's going to give me 78,400 y times delta y. Okay, well, why are we looking for force? We know that work is equal to force times displacement. So our force is the thing that we just calculated, 78,400 y times delta y. And then we want to solve for our displacement. How much is my slice of water traveling? So coming back to our three-dimensional picture, I know that from the bottom of my tank to where my water slice is, in other words, from here to here, that distance is y. And I know that from the bottom of my tank to the top of the spout, if I add 2 meters plus 3 meters, that is 5 meters, or I'll put 5 for now. And so if I want to know how far my water is traveling, then I basically want that distance. And so what number plus y gives me 5? Well, that is 5 minus y. And so my displacement here is 5 minus y. So all of that was to find the amount of work that it would take to pump out an arbitrary slice of water. And I want the amount of work that it would take to pump out all of the water. So essentially, I'm making my cross sections, and I'm making a bunch of them where they're infinitely skinny. And so we know from experience that that ends up turning into a definite integral. So my work is equal to the definite integral from my lowest slice is starting at 0, and then my last slice ends at 3, and then I have 78,400 times y times 5 minus y, and then the delta y gets changed into dy when we're changing this into a definite integral. And then this ends up equaling, if you calculate this definite integral, we end up getting 1,058,400 joules. So that is the final answer to how much work it would take to pump out all of the water from this tank. Now, before I move on to the next example, there are some things that I want to emphasize. And one of the ways that I was calculating the volume was I set up my XY plane so that I could look at the two-dimensional cross-section. And something that might be helpful to understand is I just so happen to set up my two-dimensional plane so that the bottom of my tank was at the origin. And in my opinion, I think in this scenario, that's the easiest way of going about it. However, you could absolutely get the correct answer by orienting your tank a different way. Maybe you wanted to have it so that the top of your tank was at the origin. And if you did it that way, you can still get the right answer. You just need to think about your ordered pairs slightly differently. So for example, this ordered pair right here would be negative 1.5 comma 0. This ordered pair right here would be 1.5 comma 0. And then this would be 0 comma negative 3. And if you were still thinking about this with the line segment, because earlier we found that the equation of that line segment was y equals 2x, the equation of this line segment is not going to be the same because our y-intercept for that line segment is no longer going through the origin, and instead it's going through the ordered pair 0 comma negative 3. And so that would mean that this line segment, it still has the same slope, and it would be y equals y equals 2x minus 3. And so you would need different limits of integration and such, but you can still get the same correct final answer going about doing it this way. It's just going to look a little bit different. And that leads me to my next point. I set up an xy plane in both of these scenarios, but you don't even actually have to use an xy plane. Another alternative method to get the volume of my cross-section is using the idea of similar triangles. So that's also another potential method to think about. This is just how I like doing it, but if you find a different way that works for you, please feel free to use that. Alright, so our next example says a tank is full of water, find the work required to pump the water out of the spout. We're going to do something very similar to the previous example. I want to draw an xy plane and think about what the two-dimensional front of my tank looks like. So I'm going to go ahead and draw that. Okay, so I've gone ahead and I've drawn my xy plane. Here's my y-axis and here's my x-axis. And I've also gone ahead and drawn my cross-section of water in both the three-dimensional and the two-dimensional versions of my pictures. So we want to kind of approach this in a similar fashion. I want to find the volume of my cross-section of water, but notice that in this example, my three-dimensional shape is no longer a rectangular prism, and this shape here is a circular cylinder. And the volume of a circular cylinder is not quite exactly the same as the volume of a rectangular prism. The volume of a circular cylinder is equal to pi times the radius squared times the height. And the height in this case is delta y. So we have volume equals pi times the radius, which I don't know what that is yet. And then the height I will put as delta y. So in this picture here, I'm going to call this point x comma y, and I want to find the radius, which in this case, the radius is the distance from my y-axis to that ordered pair that I just plotted on my circle. So what's going to be helpful is I know that distance is x. However, we are going to be integrating with respect to y, so I need to figure out, instead of x, what is that distance in terms of y. And the way that we're going to figure that out is we want to come up with an equation for the circle that we have graphed. Now, if you don't remember from your previous math class, the general or standard equation of a circle is x minus h squared plus y minus k squared is equal to r squared, where the center of my circle is located at h comma k, and then the radius of my circle is the value r in this scenario. And because my circle that I've graphed on my xy plane here, notice that it's centered at the origin, and that was very intentional, so it makes it easier to set up my equation. In the last example, we set up our graph so that the bottom of our tank was at the origin. Here, my center of my tank is at the origin. And again, that was very intentional because now I have x squared plus y squared is equal to the radius of the tank is 3, and we have that squared. So finally, the equation of my circle is x squared plus y squared is equal to 9. And I want to solve that equation for x, so I'm going to subtract y squared on both sides, and then I will take the square root. And normally that gives us plus or minus the square root of 9 minus y squared. I really am only wanting the positive here, so I'll just say x equals the square root of 9 minus y squared, and that's because the distance, or the point that we're looking at, is in quadrant 1, and the x value is positive there. So I forgot the squared there, and I'm going to go ahead and plug in the radius into my formula here. So we get that. And if I went ahead and I simplified this, we get volume equals pi times the square root, and the squared would undo each other, and then times delta y. Okay, so we might remember from earlier that mass is equal to the density times the volume. And we just found the volume, and we know that the density of water is about 1,000 kilograms per meter cubed. And then I'm multiplying this by pi times 9 minus y squared delta y. And now that we have that, we can move on to calculating the force, which is equal to mass times acceleration. All right, so I went ahead and I did some simplification. At this point, we can say that work is equal to the force times the displacement. So the force, I just am going to copy that down from where we just had that. And then the displacement, let's think about what that is. So I have my slice of water here, and I know that the distance from here to here is y. And because my sphere here, I know that the distance from the center of my tank to the top of my tank is 3 meters, and then the spout is an additional 1 meter. So from the center of my tank to the very top of the spout, I know that that distance is 4. So the displacement, or the distance that my slice of water would need to travel, is the distance from there to the top of the spout, and that is going to be 4 minus y. So coming back down here, my displacement is 4 minus y. All right, so we are starting to set up our work integral. So I factored out 9,800 times pi, because that's a constant. And now I'm at the stage where I want to solve for, or I want to write out my limits of integration. So where is my bottommost water slice starting, and where is my last one ending? So if I kind of draw out my rectangles to represent my slices of water, my very first one here is starting at 0, -3, and then the very last one would end at 0, +3. So my limits of integration are going to be from -3 to +3. And then we have 9 minus y squared times 4 minus y, and then our delta y gets changed into dy when we're changing this into a definite integral. And if you evaluate this, if we want an exact answer, including the pi, so this would be 1,411,200 pi, and then this is going to be joules or Newton meters, either one is fine. And if you want a decimal approximation, this is approximately equal to, let's see, 4,433,415.553 joules or Newton meters. So here is our final answer.